Okay, now we're going to look at some examples on how to calculate acceleration. Anytime you calculate acceleration, you're going to want to set up the formula triangle. So if you remember, acceleration equals final velocity minus initial velocity, Vf minus Vi, over time. In this example, we have to identify what is the final velocity, what is the initial velocity, and what is the time. Or we have to look and see what information they give us. And in this particular example, they say a man walking at 0.5 meters per second changes his speed to 5.0 meters per second over a time of 3 seconds. So, and then they ask you, what is the acceleration? If they're giving you the acceleration, that means they have to have given you the other two parts of the information. His initial velocity is 0.5 meters per second. Then they say he changes his speed to 5 meters per second. That is his VF, his final velocity, and the time is 3 seconds. So now we just need to plug it into our formula as we see above. And if you remember, it's VF minus VI divided by time. So his VF, we said, is 5 meters per second, 5.0 meters per second, minus his initial velocity, his VI, 0.5 meters per second, divided by his time, which is 3 seconds. When we calculate this out, you have 5.0 meters per second minus 0.5 meters per second, which equals 4.5 meters per second, divided by 3 seconds. So the acceleration is equal to 4.5 meters per second divided by 3 seconds, which is 1.5 meters per second every second. Or we can say it another way, 1.5 meters per second squared. Now, what does this mean? In order to get a better understanding of what acceleration is, you have to think about what that unit actually means. If I was going to draw a timeline, and we have 3 seconds of total time, so we start at 0 seconds, then we have 1 second, 2 seconds, and 3 seconds. So over that time, we said a man is walking. So when we start taking the time, he's currently walking at 0.5 meters per second. Over those 3 seconds, he starts to accelerate. So which means he's going to get faster. And how fast is he getting each second? Well, he's constantly accelerating at a constant rate. So he's going to increase his rate at the same rate every second. 1.5 meters per second every second. That's what this is saying. He increases his speed by 1.5 meters per second in the first second. So at this point in time, he would be moving at 0.5 plus 1.5 would be 2 meters per second. That's his speed or his velocity. And in the next second, over this amount of time, he once again increases his speed 1.5 meters per second. So at 2 seconds, he would be traveling at 3.5 meters per second. And then he does it again during the third second. He eventually ends up at a speed of 5 meters per second. He accelerates at 1.5 meters per second every second. That is how we kind of show what's going on here. Now our next example, use the formula triangle. Always write it down. We have a formula. Now let's read the problem and figure out what information they're giving us. So it says a train traveling at 60 meters per second must completely stop in 10 seconds. So although they didn't give us a number, they're telling us that it's going to completely stop. And when something is completely stopped, its speed is 0 meters per second. Okay? So it's initially traveling at 60 meters per second. So its VI is 60. Final velocity, its VF, is 0 when it completely stops. And it's going to take it 10 seconds. So they ask us what the acceleration is. So our VI, our VF, okay? So our VF is 0 meters per second. So acceleration equals 0 meters per second minus 60 meters per second in 10 seconds. So we have a negative 60 meters per second, because 0 minus 60 is negative 60. And remember, the negative in physics simply means that acceleration is occurring in the opposite direction. And that's why it's slowing down. So when acceleration occurs in the opposite direction, it slows down. And if you read the problem, that makes sense. A train is going from 60 meters per second to 0 meters per second. So it's slowing down. Well, how fast is it slowing down? Well, if it goes negative 60 meters per second in 10 seconds, it's slowing down at a rate of negative 6 meters per second every second, or negative 6 meters per second squared. So every second, that train is slowing down 6 meters per second. So the train is moving at 60 meters per second at this point when you start timing it. And it slams on the brakes because there's a cow on the tracks or something. After 1 second, it's slowed down negative 6 meters per second in that second. So now at 1 second mark, it's going 54 meters per second. And it does the same thing in the second. So it's now going 48 meters per second. And it's going to continue doing that. Over those 10 seconds, it slows down at a rate of negative 6 meters per second each second. So that's giving you somewhat of a visual of what's going on when we discuss acceleration. Now, just so you know, you're going to remember that acceleration in the opposite direction is indicated by the negative sign. Okay, that's a reminder there. Don't forget that. Negative in physics means opposite direction. Okay, to the original direction. Okay, let's look at another example. We should always write down our formula triangle first. Final velocity minus initial velocity divided by time equals acceleration. That also means final velocity minus initial velocity divided by acceleration equals time. And it also means that acceleration multiplied by time equals velocity. So let's see what information they give us in this one. It says a car accelerates from a stoplight, which means its initial velocity is 0 meters per second at a rate of 25 meters per second squared. This is a little bit different. Meters per second squared, that's giving you, it's telling you it's accelerating, so it's giving you acceleration. So the acceleration equals 25 meters per second squared. And it gives you the time. If the time equals 10 seconds, okay, what is the car's final velocity? Looking for final velocity up here. So it gave us an initial velocity, which is 0. So whatever we get is going to be our final velocity. The two pieces of information they give us, acceleration and time. If we plug it into the formula triangle, it's going to be 25 meters per second squared times 10 seconds. It's going to give us a final velocity of 250 meters per second. So what that's saying is for 10 seconds, that car's going to accelerate every second 25 meters per second. From the stoplight, that car in the first second accelerates at 25 meters per second. So after 1 second, it's traveling 25 meters per second. During the second, it accelerates at the same rate, so a positive 25 meters per second. So after 2 seconds, it's going 50 meters per second. Then it's going to go 75 meters per second. 4 seconds, 100 meters per second. 125 meters per second. 155, 200, 225, 250 meters per second. So every second, this car is getting 25 meters per second faster. So that's how we calculate acceleration. Please, if you have any questions, come ask us, and we'll try and help you work through these problems, okay? Have a good day.